All right, so we're going to go over question 2. So the next question, we're still talking about phosphine. So impurities cause phosphine to ignite spontaneously in air to form an oxide with phosphorus and water. Okay, and then it tells us that we have 200 grams of air and it was heated by the energy from the complete combustion of 1 mole of phosphine. Calculate the temperature rise using section 1 of the data booklet and the data below. Okay, so it gives us the standard enthalpy of combustion. So when you burn the 1 mole of phosphine, it releases 750 kilojoules. Gives us the specific heat capacity of air. And then if we look at it, so we're looking at specific heat capacity, we're talking about a temperature change, we're going to be using Q equals MCAT. So you can also go in the data book and look and find that formula. And usually when they start to reference the data book, I would go ahead and pull it out and go to that page. So we're looking for delta T. We want to know how much the temperature is going to change. And what we're doing is we're burning 200 grams of air, we're heating up 200 grams of air as we burn 1 mole of phosphine. So we're burning the phosphine, we have a container of air, and we're heating it up. So we know the specific heat capacity of the air is 1 joule per gram degree Kelvin, or we can say it's 1 kilojoule. Kilojoule per kilogram per Kelvin. So okay, so we also know we have 1 mole of phosphine and we have 200 grams of air. So we have a mass of air. There's 200 grams. Okay, so now, if we're looking for the temperature change of the air, okay, we have the C of the air, we have the mass of the air, we need to know how much heat was absorbed in this process. We also know that the heat of combustion for the phosphine is 750 kilojoules. Well, if I have 1 mole of phosphine, I'm going to burn that. I will release 750 kilojoules. And that will be per mole. Now, if I look at my specific heat capacity, it's in joules per gram Kelvin, or we could use the kilojoules, but it also has to be in kilograms. So you're going to have to make a conversion somewhere. Units are important here, so make sure you're paying attention. So let's go ahead and convert this to joules. 1 kilojoule is equal to 1,000 joules. So I will have energy of 7,500 joules. So this is my amount of energy. This is C, this is M. So at this point I can just plug it into Q equals MCAT. So Q is 7,500. My mass is 200 grams. So you could have converted the 200 grams to kilojoule or kilograms as well, but you do have to convert one of them. C is going to be 1, and then delta T is what you're looking for. So then when you solve for delta T, you're going to get 3,750. Now be careful here because the heat of combustion is negative, okay? However, okay, the phosphine releases heat as it's being burned, and then the air was being heated up, so that means that the heat, the Q for this, should be positive. So it cannot be a negative temperature change here. All right, so the oxide formed in the reaction contains 43.6% phosphorus, and it's asking you to determine the formula of the oxide, which means it's got 2 things. It's got phosphorus and oxygen. So it's 43.6% phosphorus. So we can say it's that many grams. And then it would be 100 minus 43.6 grams for the oxygen. So 56 0.4 grams of oxygen. Now, if it had more than these two elements, you would need more information. Okay, first step, convert to moles. So anytime we're finding the empirical formula, you need to know the moles so you can get the mole ratio. So 30.97 grams is equal to 1 mole. That's going to be equal to 1.4078. Do the same thing for the oxygen. 1 mole is equal to 16 grams. It's not O2, it's oxygen. So that's going to give me 3.525. All right, now we need to find the mole ratio. Divide by small. So this will be 1.4078 divided by itself. This would be 3.5 divided by 1.4078. This gives me 1. Okay, and this will give me 2.5. All right, next step, multiply till whole. Well, to get rid of the 0.5, you're going to multiply both of these numbers by 2. So this is 2, this is 5, you have a 2 to 5 ratio. So you have, your formula would be this. Okay, so let's look at the next one. All right, so the molar mass of the oxide is 285. What's the molecular formula? So to do this, you need to be able to compare the mass of the P2O5 with the mass that's given for this, so it's 285. So how many times bigger is this versus this? Well, the molar mass of this is going to be equal to 141.94, okay? That's 2 phosphorus plus 5 oxygen atoms will give me this. Well, this looks to be approximately twice as big. 285 divided by this gives me about 2. So you have twice the number of atoms. So it's going to be P4O10. All right, so state the equation for this oxide of phosphorus with water. Okay, well, we have P4O10, and I'm putting it into water. Well, it's a non-metal oxide. You're putting it into water, you're going to make an acid. Non-metal oxide plus water will give you an acid. A metal oxide plus water will give you a base. So the key with predicting this, you know it's an acid, okay, and you know it has oxygen. So it's either going to be phosphoric acid or it's going to be phosphorus. So which polyatomic are you going to have? That depends on the oxidation number. The oxidation number will not change in this reaction. So, okay, oxygen is -2. There's 10 of those, so that's a -20. So I need a +20 to cancel that out for this to be 0 overall. So each of these needs to be a +5. So between phosphate and phosphite, which one has a +5 for the oxidation state? Well, oxygen is going to be a -2, okay, and hydrogen is +1, so that's going to be +3, and this is a -8, so -8 plus a net +3, I would need a +5 to cancel that out. So my oxidation number here is going to be +5, so I do get phosphoric acid. Okay, at this point you would need to balance it. So that is going to be 6 waters and 4. So this is one of those things, it's 1 mark, so you're going to need to have a correct equation. You're also going to need to have it correctly balanced. Now, let's say that this was not correct because of the last part. If you predicted correctly with whatever your answer was, then you probably would still get the mark. All right, so predict how dissolving an oxide of phosphorus would affect the pH. Well, if you put a nonmetal oxide into water, it's going to make an acid. So that means the pH should decrease. Well, anytime that you have an acid in water, well, you're going to create ions. You're going to create hydronium ions. So the conductivity should go up because you're putting more ions and charged particles in the solution.